Um, Hello, welcome once again. Today we are going to be looking at acid, base, and salts. That's what we are going to be focusing on in today's lesson. For those of us that are just joining in for the first time, my name is Anjoni Oluwafemi Excel, and I'll be your tutor in this lesson on acid, base, and salt. Let's start off with the learning objective. It is expected that by the end of this lesson that students should be able to define acid, base, and salt and explain their general characteristics and also to be able to classify acids based and based on their strength, origin, and ionization properties, and also to be able to describe the physical and chemical properties of acids, base, and salt. And it's also expected that by the end of this lesson, students should be able to explain key chemical reactions involving acids, bases, salts, including neutralization and reaction with metals, carbonate, and ammonium salt. It's also expected that by the end of this lesson, the students should be able to identify common examples and industrial applications of acids, base, and salt, and also finally demonstrates knowledge of salts, preparation methods, including neutralization, precipitation, and titration. So let's start off by defining what an acid is. We will say that an acid is a substance that produces hydrogen ion when dissolved in water. That is what an acid is. It will produce hydrogen ion when dissolved in water. And examples of acid include hydrochloric acid, HCl, nitric acid, HNO3, sulfuric acid, H2SO4. So the acid has certain general characteristics, and some of them include taste. Acid generally are sour in taste, e.g., lemon juice, vinegar. These all contain acid, and most of us have had a taste of them. We see that they are sour in taste. So the taste of acid is sour. Regarding litmus test, acid will turn a blue litmus paper to red. And concerning regarding conductivity, acid conduct electricity when they are in aqueous solution, and then acids react with metals to produce hydrogen gas. To produce hydrogen gas. Okay, and we also know that acid also react with bases, and when they react with base, they produce what we call salt and water. It is actually a neutralization reaction that produces salt and water. So acid will react with bases and they will produce salt and water, which we call neutralization. And the pH of acid basically are less than 7. Acid will always occur in the lower range of pH scale, from 1 to about 6 point something. So acid are less than 7 in their pH value. Okay, now having said that, let's move a notch further and talk about the classification of acids. Now, acid can be classified based on their strength. We can have what we call strong acids. Strong acids are basically acids that completely ionize when they are in solution. They ionize completely. Examples are HCl and H2SO4. They are strong acid. Then based on strength, we can also classify an acid to be weak acids. These ones are partially ionized in solution. They don't ionize completely in solution. And example of such acid that we can refer to as a weak acid is ethanoic acid. That's CH3 COOH. Okay. Now, based on origin, we can also classify acid to be either organic acids. These are acids that are derived from living organisms, e.g., citric acid and lactic acid. We can also have what we call inorganic acid, which are the mineral-based, acid, e.g., nitric acid, hydrochloric acid. So we can classify acid based on origin into organic acid and then inorganic acid. We can also classify them based on the number of ionizable hydrogen atom that they possess or that they have. Now, when you have an acid that donates 1 proton, 1 hydrogen, we refer to such an acid as a monoprotic acid. Is a monoprotic acid. When you have an acid that donates 2 proton, an example of a monoprotic acid is HCl. It donates just 1 proton. And another based on number of ionizable hydrogen atom, we can also classify acid to be diprotic acids. An example of a diprotic acid is an acid that donates two protons, and we have H2SO4 as a very good classical example. H2SO4. Then we have what we call the triprotic acid. The triprotic acid donates three protons. They donate three protons. An example is the phosphoric acid, H3PO4, is an example of triprotic acid. So we have endeavored to classify acid based on their strength, based on their origin, and based on the number of ionizable hydrogen atoms that they have. Okay. If you have any question concerning this, please just feel free to drop it in the comment section, and then I will react and respond to it appropriately. Thank you. All right, let's move along now and look at properties of acids now. Properties of acid. Now, the physical properties. First, regarding their states, acid can be solid. Example is citric acid. Acid can be liquid. Example is sulfuric acid, H2SO4. Or they can be gaseous. Example is hydrogen chloride, so they can exist in different states, either in the liquid, the solid, or the gaseous phase. And their corresponding example is what I've given, accordingly. Another physical property of an acid is based on their solubility. Most acids are soluble in water. Most of them are soluble in water. Now, looking at them from the standpoint of their boiling point and their melting point, they have varying melting and boiling point based on their molecular structure. So it is basically based on their molecular structure that you have you determine the boiling point or the melting point of any acid or a particular acid. Okay. Now, based on odor, also we can give a physical property of an acid, and some acid have a distinct pungent smell. A very good example is acetic acid. For those of us that have worked with acetic acid before, you will perceive this, pungent smell. It has a distinct pungent smell, whenever you come in contact with it. Okay. That's that for that. So we have talked about the physical properties of acid, and then we take it a notch further by looking at the chemical properties of acids now. Acid will react with metals. And when they react with metal, they'll produce salts. They'll produce a salt, and hydrogen gas is always given off. So an example is when HCl reacts with zinc. Now, zinc chloride is produced and hydrogen gas is given off. Another chemical property of an acid is reaction with bases. We've talked about this before. When acid reacts with bases, they will produce what we call salts and water. And that reaction is termed neutralization reaction. So we call it neutralization reaction. An example is when we have HCl reacting with sodium hydroxide to give us sodium chloride and water. So that's a very good example. Another chemical properties of acid, we have reaction with carbonates. When acid reacts with carbonate, they'll produce a salt, they'll produce water, and CO2 will be given off as a gas. So an example is when we have H2SO4 reacting with calcium carbonate. When they react together, what you end up having will be what? Calcium sulfate, which is a salt. Then you have water being produced, then CO2 being given off as a gas. So that's the reaction with carbonate. Also, we have reaction with metal oxides. When acid reacts with metal oxide, they will form salts and water. Example is when we have hydrochloric acid reacting with copper-2 oxide to form copper-2 chloride and water. So a very typical example is what I've stated there. You have copper-2 oxide reacting with hydrochloric acid, and it gives us copper-2 chloride, and then water is also produced as a product. So these are some of the chemical properties of acids. So we want to look at common examples of acids and their uses. Common examples of acids and their uses. Now, the first one that we are looking at is hydrochloric acid. Hydrochloric acid is used in digestion and cleaning as a cleaning agent. And now, most of us eat, and whenever we feed, we ask ourselves that, oh, what are the things that are in our stomach? One of the things that are in our digestive system that helps, the digestion of food and all that is HCl, that is domicile in the stomach. It helps digestion, and it helps to create the right environment even for the digestive the digestive system, so to speak, So it is used in digestion. And HCl is a very, very fantastic cleaning agent. If you have a tough stain, a stain that does not want to come off easily, one of the things that you can introduce is the use of HCl. Once you introduce HCl, it can easily take off, those terrible or stubborn stain, as the case may be. Sulfuric acid is another example of an acid, a common acid that is we have available, and it is used in battery manufacturing and also in fertilizer. For those of us that have seen a car before, not just seen a car, but you've opened the bonnet and you have checked through and you have seen the battery that is inside, the vehicle or the car. One of the things that you notice is that there's a particular section, a compartment, whereby there's a particular liquid that is filled into the battery, that powers the car. Now that liquid is sulfuric acid. It's very, very important in batteries and car in manufacture of batteries. And also H2SO4 is very good or very important as for the production of fertilizers fertilizers that we use on our crops in order for them to be able to grow and to give us adequate yield, so to speak. So fertilizers and then in manufacturing battery. Okay. Another common example of an acid that we can also look at is nitric acid, that is HNO3. HNO3 is used in explosives. One of the components of explosive is HNO3, very, very explosive in nature. So it is used in explosive. It's also used in fertilizers too. It's used in making fertilizers, you understand. And then another acid is the acetic acid. We have talked about this, that this is an example of a weak acid. But beyond that, acetic acid is found in vinegar. Vinegar is used for so many purposes. In the kitchen, we use vinegar, for cooking and some other things like that. So vinegar, acetic acid is found in vinegar that are used in molds in a lot of processes, both domestic and industrial. Okay. Another good example of an acid is a common acid is citric acid, citric acid. And now this is used in food preservation. You want your food to last well, not only food preservation, some other items too. You want to preserve them. I want to ensure that they have longevity. One of the things that you can introduce is citric acid. It is very, very good. So it is used in food preservation and it is a good component, a very fantastic component in soft drinks. Most of us we've taken maybe a bottle of soft drink in the course of this week. One of the things that is also included in soft drinks is citric acid, citric acid. So these are some of the common acids and their uses. So we have been able to touch on that. And please, if you have any question based on what we have been discussing so far, please put them in the comment section and then I will respond to them adequately. Thank you very much. Okay, I want to talk about industrial and everyday uses of acid now. Acid can be used industrially and they can be used in our everyday activities. Now, industrial application of acid include, I've talked about this before, fertilizer production. H2SO4, HNO3 are very good examples of acid that are used in producing fertilizer. Another industrial application of acids are in the petroleum refining. It is added in petroleum refining to be able to help us to refine petroleum. Another industrial use of acid is electroplating and metal cleaning. A metal has some things on it, maybe rust or certain components that are not supposed to. One of the ways that we can clean that metal is by introducing an acid. The acid will take out the components that is an additive that is negative, and then it leaves the metal shining and bright, but we must be careful in the selection of the acid to ensure that it does not affect the metal itself, but affect, the impurity on the metal. So it is used in electroplating and also in metal cleaning. Medical uses of acid include in stomach, ACL aids digestion, ascorbic acid, vitamin C is essential for health. So that's very good. And vitamin C, especially when the weather is cold, is something that you must have handy because it guides against cold and flu and so on and so forth. So medically, we can use them in that regard. Also, and as household uses includes cleaning as a cleaning agent. I've talked about this before. We have HCl being used in toilet cleaners. Then we have vinegar, which is acetic acid for cooking and also for cleaning, and also for cleaning. So in the food industry, we use acid in different ways as a preservative. We can make use of acetic acid and citric acid and so on and so forth. In the food industry, acid is also used in beverages. Carbonated drinks that we take, contains phosphoric acid and so many other acid that we have around in the food industry that have wonderful applications in the food industry. Okay, so now we've talked about the acid. We have been able to define what an acid is. We have also been able to look at the physical and chemical properties of acid. We've been able to touch on the common uses of acids and then their various applications: industrial, medical, household, and then the food industry. Okay, so we now move along to bases now, and we start off with a definition that a base is a substance that produces hydroxyl ion when dissolved in solution. It produces hydroxyl ion when it is dissolved in solution. Now, we said bases are substances that accept hydrogen ion and releases hydroxide ion in solution. So we can look at them from two angles. They produce hydroxyl ion when they're dissolved in solution. They're substances that accept hydrogen ion or releases hydroxide ion in solution. Okay. Now, some of the general characteristics of bases include: number one, they have a bitter taste, e.g., baking soda and soap. And for some of us that have titrated before, and in the course of titrating, you're trying to pipette maybe 25 or 20 cm per mil of the base, and all of a sudden you find the thing in your mouth. You know the taste that you have. It's bitter in taste, so to speak. So bases are basically they are bitter in taste. They are slippery to touch. When you touch them, they are slippery to touch. So another general characteristics of bees is that they will turn a red paper to blue. They turn red litmus paper to blue. So when you bring a solution and you put it on a red litmus paper and it turns to blue, know definitely that that solution is a base. Another property or general characteristics of bases is their conductivity. In aqueous solution. Then we talk about their reaction with acid. When base react with acid, what happens is that they undergo what we call neutralization, and they form what? Salt and water accordingly. Bases basically has a pH value that is greater than 7. So you start finding base on the pH scale at a pH that is greater, than 7. So they basically have a pH that is greater than 7. Okay, so let's look at some classification of bases too. Based on their strengths, we can classify bases to either be strong base or a weak base. A strong base will completely ionize in solution, just like we have with acid too. So a strong base will completely ionize in solution. Example of a strong base or example of strong bases are sodium hydroxide, potassium hydroxide, and even calcium hydroxide. Now, weak base on the other end will partially ionize in solution. They will partially ionize in solution. So you can see a clear-cut difference now. A strong base will completely ionize in solution. A weak base will partially ionize in solution. So example of weak base include ammonium hydroxide, aluminum hydroxide, and so on and so forth. Now, based on solubility, we can also classify base or bases into alkalis, and insoluble base. Alkalis are bases that dissolve in water. So we can classify them as alkalis, which are the soluble base. They dissolve in water. Examples of such are sodium hydroxide and potassium hydroxide. We can also have insoluble base. Based on solubility, we can classify a base to be insoluble, insoluble base. And these are bases that do not, naturally, they do not dissolve in water. So example include copper hydroxide and iron hydroxide. So we have those classification based on solubility. Okay, now let's talk about their properties now. And in looking at the properties of bases, we have to start with the physical properties of bases. Now, the first one is to look at their properties based on their states, their states and matter. Now, we can have them to be solid, e.g., sodium hydroxide and calcium hydroxide. Sodium hydroxide looks like a pellet, calcium hydroxide looks powdery. So they can be solid or aqueous. Aqueous means that it can be in a liquid format, in solution. So ammonium hydroxide is an example. So that's one physical property of bases. They can either be solid or they can be aqueous. Now, based on their state. Now, based on solubility, we can have some to be highly soluble in water. We refer to them as alkalis, while others are insoluble in water. Now, based on odor, we have some weak bases like ammonia having a strong pungent smell. Oh my God. The smell of ammonia it can be sickening, as in very, very terrible. For some of us that have had to use ammonia before in the laboratory, oh my God. Oh my God, oh my God. It's a strong pungent smell. I remember the first time I had to use ammonia in the laboratory. I was not with my nose mask that day, and I regretted it, because it has a very strong, pungent and very, very persistent smell. So based on odor, some weak bases like ammonia have a pungent smell. Why others like strong bases don't really have the smell, so to speak, like that. And also based on texture, bases are slippery when dissolved in water. When you touch them, you feel that they are slippery. They will just be sliding on your hand, so to speak. So these are the physical properties of bases, and then we look at the chemical properties of bases now. Now, the first thing is reaction with acid. We've said this and we can't say it enough. When base react with acid, they would give us salt and water, and that's a neutralization reaction. They also react with metals. When strong bases react with certain metals, they will form hydrogen gas, like sodium hydroxide and zinc. Now, when they react together, hydrogen gas is given off like that, and then we have the corresponding compound being formed. Now, reaction with ammonium salt. Now, when bases react with ammonium salt, they will produce salt, water, and ammonia gas. Sodium hydroxide reacting with ammonium chloride is a very good example to give us sodium chloride and then water and ammonia that is given off. Okay. Now, common examples of bases and their uses. What are some of the common examples of bases and how can we use them? Okay. Sodium hydroxide is the first base. It's a very common base and it is used in soap making and drain cleaners. So we use them in soap making, and it's also used as drain cleaners. And potassium hydroxide is another common base. It is used in alkaline batteries. Yes, there are some batteries that are alkaline, base. So it is used in alkaline battery. Calcium hydroxide is used in cement and plaster. Ammonium hydroxide is found in household cleaners, and then magnesium hydroxide is used as an antacid, and it's very, very important for those of you that have had a heartburn before, and they ask you that, oh, go and take something, and just give you that thing. You don't even know what it is, but you just discover that the moment that thing entered into your stomach, you have a massive relief. What you have been given is an antacid that guides again acid reflux, or when we have, heartburn, so to speak, maybe from eating certain food and so on and so forth. So magnesium hydroxide is a very good component of antacid that is used as a remedy for heartburn and acid reflux issue. Okay. All right. So industrial and everyday uses of bases, just like we did with the acid, I just want to do the same thing with the base too. So industrial application, bases are used in soap and detergent manufacturing. They are used in paper production. They are used in textile industry, ammonium solution to be precise. So they are used in textile industry. Medically, you find bases being used as an antacid for acid reflux. I've made mention of these before. That's magnesium hydroxide, and they are used in medical soap and antiseptics. Okay, now I haven't said this in the food industry too. Uh, bases can be used, as a leavening agent. A very good example is the what's it called? Sodium hydrogen carbonate. So, baking soda, that sodium hydrogen carbonate is used as a leavening agent, just like I said before. So these are some of the uses in the food industry. It's also used in as a food preservative, It's used as a preservation in food. So that's that concerning that. So household uses for household uses, you have bases can be used as a cleaning agents, and they can also be used as drain cleaners and oven cleaners. Okay. Okay, this was duplicated. So that's basically it. These are some of the applications, industrial and everyday uses of the base. Okay. So please, if you have any question, if you have an area you want me to expand on to talk more about, please feel free to let me know in the comment section and I will do justice to it. Thank you. All righty. So we don't want to go into salt now. We have considered base. We have defined what a base is. We have talked about the classification of a base. We have equally looked at the physical and chemical properties of base. And we have also looked at their uses, industrial, medical, household uses, food industry, and so on and so forth. So we have touched on all that, which is very, very good. So we want to take it a step further by looking at salt, because part of what we have in our syllabus for the jam chemistry is we want to look at acid, look at base, and then look at salt. Now, so salts are basically ionic compounds that are formed from the neutralization reaction between an acid and a base. They are formed from the neutralization reaction between an acid and a base. Okay, so what are the general characteristics of salt? Number one is based on their composition. So they are made up of positively charged cations and negatively charged anions. Okay. Based on their taste, many salts have a characteristic taste. They have their own peculiar characteristic taste. Like take for example, sodium chloride. Sodium chloride is salty, based on solubility, some salts dissolve easily in water, while others are insoluble in water. Now, based on their conductivity, salt conducts electricity when dissolved in water. So they are electrolytes, basically. Their pH nature, they can be neutral, they can be acidic or basic, depending on their parent acid and base. So salts can either be neutral, they can be acidic or basic, and this is all dependent on their parent acid and base. Okay, all right. See, so we look at the types of salts that we have now. Now, the first type we have is what we call the normal salt. The normal salt. This calls normal salt because it is completely neutral. It's completely neutral. A very good example of normal salt is sodium chloride is an example of a normal salt because it is completely neutral. Then potassium sulfate is another example of a normal salt. So we can also have what we call the acid salt, which contains replaceable hydrogen ions. So these are like examples. Sodium hydrogen sulfate is an acid salt. It contains replaceable hydrogen ion. Then we have the basic salt. The basic salt contain replaceable hydroxide ions. Like take for instance the BiOH NO3, bismuth, the hydroxide nitrates, these are examples of uh, um, examples of just a minute. These are examples of a normal soup. Yes. A máa dúpẹ́ lọ́wọ́ Ọlọ́run máa ṣe wọn. So just like well, we've talked about, salt, we've defined what salts are. Another thing that we need to look at are the types of salt. And we have salt to either be normal salt, acid salt, basic salts, double salt, and complex salt. A salt is said to be normal because it has been completely neutralized. It is completely neutral, so to speak, So example of a normal salt is sodium chloride and potassium sulfate. We also have acid salts. And we say a salt is acidic because of the fact that it contains replaceable hydrogen ion. Like example is sodium hydrogen sulfate. Then we have basic salt, which contains replaceable hydroxide ion. So that's a basic salt. Then we have the double salt, which contains two different cations, then we have the complex salt, which contains complex ion. So potassium ferrocyanide is an example of a complex salt. Okay, all right. So we look at the properties of salts now. Based on their state, we can say that most salts are crystalline solids, Based on solubility, they vary, their solubility varies, Sodium chloride is highly soluble, while silver chloride is nearly insoluble. They are melting and boiling point. Please pardon me. They have generally high melting and boiling points, and this is due to the existence of ionic bonds between the element that makes up the salt, So they generally have high melting and high boiling points. Now, in terms of their hygroscopic nature now, some salts absorb moisture from the air, example is calcium chloride, and they can be very useful too in the lab because we use them as a drying agent. Okay. In terms of color, either they vary in color also. Some salts are white, like sodium chloride. Some are blue, like copper sulfate, and others colors based on the metal ion that is a component of the salt. Okay. Now, properties of salt. In terms of their chemical properties now, reaction with water, which we refer to as hydrolysis. So when some salt form acidic or basic solution in water, e.g. ammonium chloride gives an acidic solution, okay? They also react with acids, and when they react with acid, they will form a new salt, and then a new acid is also formed. Interesting phenomenon. So when a salt reacts with an acid, it will form a new salt and it will form a new acid. A very good example is sodium chloride reacting with H2SO4. What happened is that you have what sodium hydrogen sulfate, which is a salt being formed, and then a new acid, completely new acid, HCl, is also formed, reaction with bases too. The same phenomenon come into play here too. You have salt plus base giving us a new salt and then the new base. So example is copper sulfate reacting with sodium hydroxide, giving us copper hydroxide and then sodium sulfate, So a new salt, a new base is being formed in that regard. All right, so we also have another property which is reaction with other salts, which we call double decomposition. AgNO3 reacts with NaCl and gives us AgCl and then NaNO3. Okay. Okay. Preparation of salt now. Preparation of salt. Neutralization method is one of the ways we prepare salt. We've touched on this so much in the course of teaching. When acid reacts with base, it will form salt and water. This is a method for producing salt or preparing salt. So it is used in preparing soluble salt of sodium, potassium, and ammonium. Now, reaction with acid metal is another method that we can use to prepare salt. And when a reactive metal reacts with an acid it will form salts and then hydrogen gas. So we have a very classical example, zinc reacted with HCl to give us zinc chloride and then H2, which is giving off. That's the hydrogen gas. So this particular method is used for preparing soluble salts, but not suitable for highly reactive metal like sodium and potassium. So that's the limitation with this particular preparation method. Okay. So we can also have reaction of acid with metal oxide, when we have acid reacting with metal oxide, which are bases, and they will form what? Salt, and they will form water. Example is where we have copper, CuO plus H2SO4 to give us copper sulfate plus H2O. So when copper 2 oxide react with H2SO4, it gives us what? Copper sulfate and then H2O, which is the another method of preparing acid. Now, this particular preparation method is commonly used to prepare insoluble salt. So we must take note of that. Another method of preparation of salt is the reaction of acid with metal oxide. When acid react with metal oxide, they'll give us salt and then they'll give us water also. So we have talked about this before. I think that's a little repetition. Please pardon that. So it's commonly used to prepare insoluble salt. Okay, insoluble salt. So we can also have reaction of acid with metacarbonate. And when that happens, you have a salt that is produced and also carbon dioxide that is given up. And this particular method is used to prepare soluble salt. It is used to prepare soluble salt. Then we have precipitation method, which we call the double decomposition reaction, whereby two soluble salts react to form an insoluble salt, precipitate, and a soluble salt. So when we have AgNO3 plus NaCl, then we have HCl precipitate and then NaNO3, which is the soluble salt that is produced. So you produce insoluble, so it is used to prepare insoluble salts such as AgCl and barium sulfates. We can also produce salt or prepare salt, please, using what we call direct combination of elements. So some salt can be prepared by directly reacting, the elements, So we can have iron and chlorine reacting together. And when that happens, it will give us what's iron chloride, And then, and this particular direct combination method is used for producing highly reactive metals and non-metals. So it's used for salts of highly reactive metals and non-metals. We can also produce salt through titration, for soluble salt of group 1 and ammonium salt, we can use titration method. So a strong acid is titrated with a strong base and the solution is evaporated to obtain the salt, An example is H2SO4 plus sodium hydroxide, and then you have that being produced. So titration method is used for preparing pure soluble salt. Pure soluble salt. Okay. All right. So let's look at some comparison of salt preparation methods. We have mentioned different methods of preparing salt. So let's compare these methods. Let's start off with neutralization. Neutralization is suitable for soluble salts. Soluble salt like NaCl and K2, K2SO4, you understand? That's for neutralization. Acid plus metal. When you have acid reacting with metal, it will also produce soluble salts like zinc chloride, magnesium sulfate, and so on and so forth like that. When acid reacts with metal oxide on the other hand, it will produce insoluble salts like copper sulfate, Then when acid and carbonate react together, they produce soluble salt. Example, calcium chloride. We can also use the precipitation method, which produces insoluble salts, An example is when we have our silver chloride and the barium chloride, you understand? Then we have direct combination, which we use for producing reactive element salt or salt that are the constituent elements are very, very reactive. And then we can also use titration as a method of producing salt, So it is used to produce soluble salt also, like sodium sulfate. So these are the method for salt production and their suitability, as the case may be. Okay. So common examples of salt and their uses is the next thing that we want to look at. So we want to look at some of the common examples of salt and what they are used for. Sodium chloride is a very good example. It's called common salt. It's a table salt and it is used in food, we use it in food preparation and also for food preservation. You don't want your food to go bad. One of the ways that we can use is by doing what we call the salting method. Calcium carbonate is another example of the salt, which is CaCO3, and it is used in cement and tile seed. Then copper 2 sulfate is used in agriculture as a fungicide. It's used in agriculture as a fungicide. Then we have the sodium bicarbonate, sodium hydrogen carbonate, which is the commonly referred to as baking soda. It is used in cooking and also it is used in medicine. Then we have ammonium nitrate that is used in fertilizer. It's a very major component of fertilizers. So it is used in fertilizers. It's also used in explosives too. So these are some of the common salts and their uses. So when we look at their industrial and everyday uses, just like we did for acid and the bases too, we want to replicate the same thing for salt now. And industrial application, we can manufacture chemicals and glasses using salt. And it can also be used in metallurgy and dyeing process. So salt can be used in metallurgy and dyeing process. Also in medically, salts like Epsom salts are used in medicine, very good in medicine. Sodium bicarbonate is another example that is used in treating acid reflux. Then in the food industry, it is used as preservative and flavor enhancer, like example are like sodium chloride, potassium nitrate, and so on and so forth. It's also used in food processing and curing. It is used in food processing and it's also used in food curing also. Okay. So also the uses they are limitless, but some of them they are using water as a water softening agent, like sodium carbonate is used as water softening. They're also using as cleaning agents and as detergents, like we have for boras. So these are some of the industrial and everyday uses of salt. These are some of the industrial and everyday uses of salt. Okay. So we move along now and talk about the basicity of acids. The basicity of acid. But let's take a breather and quickly reflect. So far, we have been able to look at the acid. We have defined them. We have also been able to look at the classification. We've classified acids and then we have classified them into strong, weak, based on their strength, based on their solubility, based on their hydrogen ion, the number of hydrogen that is ionized and so on and so forth like that. So we have classified acid. We have done the same thing for bases too. We have defined acid, we have given a classification, we have talked about their industrial, household usage, and so on and so forth like that. Okay. We've also touched on the salt also. We have defined what the salt is. We have equally looked at the general characteristics of salt and then how they are prepared. And then we have tried to make a comparison between the preparation method for salt and we have also talked about their uses, also industrial uses, household uses, in food industry, and so on and so forth like that. So we have done all that. So we want to now go on and look at the basicity of an acid, which is another item that we must touch on based on the syllabus, the JAM chemistry syllabus. And please, if you are not so clear about maybe certain concept that I've touched on in the course of this teaching, please do well to put them in the comment section so that I can address it and give you clarity, very, very important. Okay, so basicity of an acid refers to the number of hydrogen ion an acid molecule can donate in an aqueous solution. So it refers to the number of hydrogen ion an acid molecule can donate in an aqueous solution. So basicity of an acid refers to the number of replaceable, this is another definition now, number of replaceable hydrogen atoms in one molecule of the acid. Number of replaceable hydrogen atoms in one molecule of the acid. Now, it determines how many hydroxide ions are required to completely neutralize the acid. So the basicity of the acid will determine, we need X amount of hydroxyl ion, hydroxyl ion to be able to neutralize, the acid and so on and so forth. So basicity is an important property in acid-base reaction and industrial application. Now, classification of acid by basicity. We can classify an acid into one, monobasic acid. A monobasic acid has a basicity of 1. It can donate 1 hydrogen ion per molecule. Example of monobasic acid are HCl, HNO3, and then ethanoic acid, CH3COOH, okay? And then we have the dibasic acid. The dibasic acid they have a basicity of 2. They can donate 2 hydrogen ion per molecule. Examples are H2SO4, H2CO3, and so on and so forth. We also have what we call the tribasic acid. The tribasic acid have a basicity of 3. They donate 3 hydrogen ion per molecules. Example is phosphoric acid, is an example of a tribasic acid. Okay. So we have done classification of acid based on by basicity now. Now, we want to look at the method for determining basicity of an acid. If we want to determine basicity, we can either use number 1, a theoretical determination method, which is based on the molecular formula of the acid. So we identify the number of ionizable hydrogen atom in the chemical formula. Example, like H2SO4, which has 2 replaceable hydrogen atom. So hydrogen ion, pardon me, please. So the basicity of H2SO4 is what? Is 2, based on the number of hydrogen ionizable hydrogen atom that it contains, So that is based on the theoretical determination method. Now, we can also look at it from the angle of ionization in water. So we can determine basicity of an acid based on the ionization in water, like electrolytic dissociation method, We observe the hydrogen ion released in solution. Example, when you have H2SO4, when it dissociates in 2 steps. The first one is that you have the H2SO4 giving us an H hydrogen ion, then HSO4 minus, Then after that, that will dissociate further to produce another hydrogen ion, and then SO4 2 minus. So since it donates 2 protons or 2 hydrogen ions, please, basicity of H2SO4 is what? Is 2. So based on the ionization in water, we can determine the basicity of acid. We can also determine it using the theoretical determination method. Okay. All right. So we can also use what we call the acid-base titration method. So we can use the acid-base titration method to determine basicity of an acid. So the acid is titrated with a strong base, e.g. sodium hydroxide, and the number of moles of base required for complete neutralization is determined, So when you have HCl, which is a monobasic acid, you discover that 1 mole of sodium hydroxide will neutralize 1 mole of HCl. So it then connotes that the basicity of HCl is 1 based on the acid-base titration method. And you can also see that with H2SO4. And so you say the basicity is 2, because 2 moles of sodium hydroxide will neutralize 1 mole of H2SO4, because H2SO4 is dibasic in nature. Okay. Another method to determine basicity of an acid is the salt formation method. Now, the number of hydrogen atoms replaced when the acid reacts with the base determines its basicity. Let's use this as an example. You have HNO3 reacting with sodium hydroxide. What happens is that you have a sodium nitrate plus water. So what happens there is that you have just one hydrogen atom that is being replaced, when the acid reacts with the base, For H3PO4, this is not the case. In this regard, you have about 3 replaceable hydrogen atoms. You need 3 moles of the base to react with just 1 mole of phosphoric acid. So the basicity in this regard is what is 3 because of the replaceable hydrogen ion that we have in phosphoric acid. Okay, so that's that for that. So please let's move along now. And look, okay, I think I was thinking I still have more to share. Okay, so let's summarize and the lesson so far. We've talked about acid. We have defined what they are. We have looked at their general properties. We have classified them. We have done classification in different dimensions based on strength, based on origin, based on ionizable hydrogen atoms, and so on and so forth. And then we have also stated their common use and so on and so forth. Okay. We've also touched on base. We did almost the same thing with base too. We talked about we defined them. We looked at their general properties, we classified them, and then we looked at their common uses. And we also touched on salts too. In looking at salts, we have talked about what they are, their general properties, the types of salts we have, and the common uses of salt, and then their key chemical reactions was also touched on. So please, that brings us to the end of this lesson. So please do well. If you don't understand anything that I've said so far, please call my attention to it in the comment section, and then I will address it appropriately. So let's evaluate our lesson. The first question we have here is, which of the following is a general property of acids? Which of the following is a general property of acids? Let's look at the options that we have there and tell me what the answer is in the comment section. Tell me what the answer is in the comment section. Then we have number 2 is a strong acid is one that tastes bitter. B, partially ionizes in solution, completely ionizes in solution, has a pH greater than 7. So what do you think the answer to that question is? Please put it in the comment section, and then I will react appropriately. Which of the following is a weak acid? Which of the following is a weak acid? So let's look at all the acid listed from option A to D, and tell me in the comment section which one you feel is a weak acid to in that lineup. Okay. We also look at question number 4 now as we evaluate for that. Which of the following is an insoluble salt? Which of the following is an insoluble salt? So let's look at the salts one after the other. And please tell me which one you feel is an insoluble salt. Which of them is an insoluble salt? So you let me know in the comment section. Okay. The next one is, what is the reaction of a base with ammonium salt called? What is the reaction of a base with ammonium salt called? Is it precipitation? Is it double decomposition? Is it neutralization? Is it ammonia liberation reaction? So tell me in the comment section what you feel the right answer is, please. What is the reaction of a base with ammonium salt called? I think that's a repeated question, so please, we just skip that. So just tell me what you feel in the comment section, and I will react accordingly. The next one says that what color change occurs when a base is tested with litmus paper? We've touched on this, so this should not be too difficult for you to be able to provide me an answer. So look at the options and tell me what you feel the right option is in the comment section. So what is the pH range of a basic solution? What is the pH range? Is it 0 to 7? Exactly 7, 7 to 14, or 1 to 10, So put your answer in the comment section, and then I'll pick it up and react appropriately. Which base is commonly used in soap making? Yes, we touched on this, or we talked about this in the course of the teaching. So let me know what the answer is. Okay, thank you so very much for listening and for giving me your rapt attention as I explain acid-based and salt. Please go over the notes again and try as much as possible to understand all the concepts. We have a part 2 of acid, base, and salt, which I'm going to be sharing very, very shortly with you. So please do well to still connect, and you'll see the part 2 as we push it a notch further. Thank you. I'll see you in the next video.